What's up, everybody? Today we are going to be talking about the exciting world of geometric shapes and area for Introduction to Engineering Design. And we're going to start off with the definition, and the definition we have here is shape. And a shape describes the two-dimensional contour that characterizes an object or area in contrast to a three-dimensional solid. So we have circles, we got ellipses, we got triangles, polygons, squares, rectangles. All of those things are shapes. You learned them when you were 2 or 3 years old, and hopefully you have not forgotten them. Next definition is area, is the extent or measurement of a surface. So all shapes represent enclosed two-dimensional spaces and thus have an area. So the shaded region for the circle, ellipse, and triangles below are the areas of those shapes. A circle is a round plane whose boundary consists of points equidistant from the center. The circle is the simplest and strongest of all the shapes. Circles are found within the geometry of countless engineered products such as buttons, tubes, wires, cups, and pins. A drilled hole is also based on the simple circle. We deal with circles all the time. Look, I have a circle here in my Russell mug. We can find the area of the circle by using the concept of pi. Pi is the ratio between the circumference of a circle and its diameter. The ratio states that for every unit of diameter distance, the circumference will be approximately 3.14 units. We had Pi Day just the other day. Unfortunately, we missed it because I think it was a Sunday. So hopefully you celebrated and ate some pie that day. To calculate the area of a circle, we must know the radius, or the diameter. We can divide by 2 to get the radius, and area equals pi r squared. Pi is approximately 3.14. R stands for radius, A stands for area. An ellipse is generated by a point moving in a plane so that the sum of its distances from two other points, called the foci, is constant and equal to the major axis. To calculate the area of an ellipse, the lengths of the major and minor axes must be known. The area is pi times a times b, where a is the major axis divided by 2, b is the minor axis divided by 2. And pi, again, is 3.14. A polygon is any plane figure bounded by straight lines. Examples include the triangle, rhombus, and trapezoid. An angle is the figure formed by the intersection of two rays. Angles are differentiated by their measure. So an acute angle is less than 90 degrees. A right angle is exactly 90. Obtuse is between 90 and 180. And a straight angle is 180 degrees. A triangle is a three-sided polygon. The sum of the interior angles will always equal 180 degrees. All triangles can be classified as a right triangle, an acute triangle, or an obtuse triangle. The triangle is the simplest and most structurally stable of polygons. This is why triangles are found in all types of structural designs. Trusses for bridges are one such example, and it's something that you will study extensively in Principles of Engineering. Sometimes the terms inscribed and circumscribed are associated with the creation of triangles and other polygons, as well as area calculations. So here we have an inscribed triangle, inscribed in a circle, and here we have a circumscribed triangle around a circle. The area of a triangle can be calculated by finding 1/2 times the base of the triangle times the height of the triangle. A quadrilateral is a four-sided polygon. Examples include the square, rhombus, trapezoid, and trapezium. A parallelogram is a four-sided polygon with both pairs of opposite sides parallel. Examples include the square, rectangle, rhombus, and rhomboid. The area of a parallelogram can be calculated by base times height. A regular polygon is a polygon with all sides equal and all interior angles equal. A regular polygon can also be inscribed in a circle, like an equilateral triangle. An inscribed polygon is a polygon placed inside a circle so that all the vertices of the polygon lie on the circumference of the circle. We can also circumscribe a polygon around a circle. so that the sides of the polygon are tangent to the circle. Examples of regular multi-sided polygons include the pentagon, hexagon, heptagon, and octagon. The area of a multi-sided regular polygon is found by multiplying the number of sides times the side length squared divided by 4 times the tangent of 180 divided by the number of sides. That's all the information I have for you today, so go ahead and jump into the activity that I have for you. If you have any questions, go ahead and shoot me an email or comment on the activity itself. Talk to you soon.